So that we estimated the model and generated the samples and the posterior predictive, we're going to look at what the results actually are of the model. So we're going to look at the summary table of our posterior distribution. So, and we're going to specify the variables that we're going to be interested in. So there's going to be the variable on the female dummy. We're going to be interested in GDP. We're going to be interested in the interaction effects between the female dummy and GDP. We want to know the effect of income inequality on mortality. And then we get the lifestyle variables related to smoking, body mass index, and binge drinking. And then the summary of our data, posterior normal, and from that we're interested in the posterior distribution, the variables health. So I'll leave it to you to look at the posterior plots, to make the plots with the posterior distribution and check the zigzagging of the posteriors and how they were sampled. Here we're going to basically look simply at, let me do this slightly, so it's easier for us to see the actual table. So the first thing we're going to look at is R hat. And as you can see, all the R hats are close to 1, in this case, in fact, equal to 1. So that suggests that we can have some faith in the sampling process. Then if you look at the coefficients, we see, which we already saw in the figure when we started, is that mortality for women is lower than for men. So the mean of the posterior distribution for B female is minus 0.26. And if you look at the 49% credibility interval, it's the value of the coefficient lies between minus 0.39 and minus 0.1314. The effect of GDP is that higher levels of GDP will decrease mortality. Again, that's what we would expect. Richer countries have lower mortality. The interaction effect between GML and GDP is positive. Yeah, so that means that this negative effect becomes smaller as GDP increases. Yeah, so for low values of GDP, this value is about 0.26. But when we start to increase GDP, this value basically becomes smaller and smaller. Yeah, so that's the interaction effect. It's positive, meaning that as GDP increases, the negative effect of gender on mortality, that negative effect is decreased in absolute value. Yeah, so it becomes closer to 0 basically. As you may expect, income inequality actually increases mortality. So for a given level of GDP, as income inequality increases, mortality will increase. Yeah, so this is the idea here might be that there are decreasing returns to spending on healthcare. So if somebody is has a higher income, we expect him to spend more on healthcare, yeah, because healthcare is probably a normal good. But then this increase in income, and therefore the consequent increase in healthcare expenditure, this healthcare expenditure gain is smaller than the loss that we get from the lower incomes, which we're going to have as inequality increases for a given level of GDP per head. Yeah, so that means that the poor basically are foregoing treatments that have very high value because they have low income. And although the richer people spend more on healthcare, what they gain is going to be less than what the poor are losing in terms of health. Yeah, so that's an idea of decreasing returns to spending. Yeah, so first you spend your money on the most valuable treatments, and as you get more and more income, you start to spend it on treatments that have less and less value added. Yeah, so that causes this idea that an increase in income inequality will lead to an increase in mortality. The effect of smoking is not very precisely estimated. Yeah, so the effect is negative, but when you look at the standard deviation of that posterior distribution, you can actually see that the standard deviation is far bigger than the mean. It's more than twice as big. So when you look at this 94% interval, it's not clear that the effect of smoking is either negative or positive. Yeah, so this is different with high body mass index and with binge drinking. They both clearly lead to higher mortality. Yeah, so the credibility interval, so the 94% interval, is clearly positive for both binge drinking and people with a high body mass index. Yeah, so that's how we interpret these coefficients. Then let's quickly look at posterior predictions. So we have this, we're plotting again our data, the data that we had before. So so we have very similar things in terms of the color map that we're using. The only difference is that before we only had this scatter plot, but now we also plot the percentiles. Yeah, so we plot the percentiles for mortality for each level of log GDP. Yeah, so these two lines here, the V lines, the vertical lines, are added compared to the plot that we had before. And then we can run this code. And we get the figure. And again, so the vertical lines basically show you this intervals. I think we're plotting here the 95% intervals. And the dots are the observed values. And as you can see, so the model seems to be doing quite reasonably, in the sense that the intervals are very close and sometimes in the middle of the observed values, or basically the observed values are in the middle of our prediction. Yeah, so we seem to be doing quite well. Some exceptions here where it's more at the top. Of course, it can even be the case that some of these observations do not lie within this interval, as seems to be the case here, because it's the 95% interval, so 5% of the observations can be outside of this interval. But judging from this posterior predictive, it's actually the model fit seems to be fairly good.